afternoon. I'm the last one between you and getting out for the day.
No posters.
Oh, posters, sorry. Very important, that. So, take a front row seat in a new era. It is an era in which man has created for his own better enjoyment of living a whole new set of materials called plastics. They behave as no materials have before them ever behaved. So announced the 1947 House Beautiful Special Edition on Plastics. Oops. The subtitle was A Better Way to a More Carefree Life. Many did heed the call to plastics, and they're now used extensively, and I defy any of you not to have been using plastics today. It's impossible to get through a day without plastics. At the beginning, not everyone was quite so enamored of this material, and while Richard Benjamin in The Graduate was able to reject the call, conservators do not have that choice. Plastics are completely pervasive throughout our entire environment. And as we move through the 21st century, we are finding in a new era for conservation where we will be working with mid-century modern materials, particularly plastics. Now, plastics is actually an umbrella term, as there are many different types of plastics. I'm going to use two case studies to illustrate this talk and to illustrate the difficulties of making decisions with this. And the subset of plastics we're going to be looking at today is fiberglass reinforced plastics, which come under the thermosets. Now, the two case studies are sort of quite different, even though they're similar materials. One is quite simple, one's complex, one's completed, obviously the simple one, and one's still in study phase. But both of these studies were part of the 1964-65 World's Fair in New York City. So we're continuing the theme. So let's begin by taking a little bit of a look at what fiberglass reinforced plastics are. Now, everybody has seen fiberglass reinforced plastics, and here's two very common uses of them. Now, while the development of FRP began in 1930s, it's not really begun being used in manufacturing until the mid-20th century. Fiberglass was discovered by accident in 1932 when a jet of compressed air inadvertently hit a molten stream of glass. The resulting spray of fine glass was something that researchers have been working for years on. In 1936, two glass companies, Corning Glass and Owens, Illinois, figured out how to do a mat, and the glass cloth they named fiberglass with one S. They were looking for a resin to embed it in. DuPont actually by 1936 had come up with this resin, but they had trouble with the cure times. The Germans, on the other hand, did find a solution. So at the very beginning of the Second World War, the British intelligence agents stole the secret from them and brought it to the US, where they gave it to American manufacturers. Now, Ray Green was a boat builder in this country, and he used this polyester resin to reinforce glass cloths, and he actually made a fiberglass reinforced plastic boat in 1942. So war uses were really quickly found for this material. Of course, after the war, you had to find some new industry here, or new uses. So with the post-war construction boom, FRP industry immediately went to the construction industry. And it was very attractive because here's a material that's lightweight with high strength. And an opportunity to showcase this material came about with the 1964-65 World's Fair, particularly as the manufacturers had a dominant role in this fair. Now, there were basic requirements, which you've sort of heard a little bit about previously, about building here. One of them was they had to be inexpensive. They had to be easy to erect and very easy to disassemble. As the fairground, of course, as you heard, had to go back to being a park. So New York City waived its 20-year longevity building code for this fair. However, the strength and stress requirements remained in effect. What better opportunity to demonstrate the use of modern materials, such as plastics, fiberglass, stainless steel, and tempered glass? Now, Owens Corning Fiberglass estimated that 1 million pounds of glass fiber was used at the fair to build about 24 fair pavilions, as well as telephone booths, dinosaurs, and roofs. And I'm guessing the money that came from this was what went into, enabled them to build that fiberglass tower that we heard about yesterday. The designs used here were often mid-century modern. They could be kitsch, and of course there was a futuristic element in many of them. And mind you, all three sort of attributes were found. While corporate pavilions with distinctive designs dominated the literature of the fair, we're going to examine three small-scale examples of fiberglass. These remnants have acquired significance because they are part of the very few remaining relics of this fair that remain in situ. Excuse me, I'm suffering from enormous hay fever here. The parks in 2014, New York City Parks contacted me as they were wondering whether the Columbia University Historic Preservation Program Conservation Workshop would be willing to conserve a 1964-65 World's Fair bench. What they wanted was they wanted at least one bench to go to the Queen's Museum, so this was to be the bench. How could one possibly turn down such an opportunity to work with such good plastics? 4 students, Catherine Gardner, Corey Manchenden, Marina Wisniewski, and Donna Yu took up the challenge to work on these benches. The 1964-65 World's Fair was spread out over nearly a square mile of land. People's feet got tired, they got weary, and benches were an obvious solution. By the way, this is an actual photograph from the fair. So, as benches were an obvious answer, 3,500 fiberglass slat benches were installed at a cost of $352,000, or about $100 a bench. Inexpensive. Today, there are less than 3 dozen benches left. Now, the 8-foot benches have a nice, sleek, minimalist design, very deco looking in a way, and they were done by the architect Gilmore Clark and his firm, who are actually working for Robert Moses, who is, of course, as you heard, in charge of the fair. The benches have 3 legs, 8 slats, 5 slats for the seats, 3 slats for the backrest. The fiberglass slats were molded using a pigmented resin, and they also had aluminum legs. Now, 2 separate companies manufactured these benches. Hamden Brass and Aluminum Company of Springfield, Massachusetts cast the aluminum legs, and the Universal Molded Fiberglass Corporation of Bristol, Virginia did the fiberglass slats. The benches were supposed to be maintenance-free. They were supposed to be unpainted, although the aluminum legs had to be lacquered. Now, the Universal Molded Fiberglass Corporation is now part of what is called Strongwell Corporation. And if you look on their website, you'll find that they've been working with plastic since the mid-1940s. And what's interesting is they were using a fabrication process since somewhere around the mid-1950s called the continuous automatic process, which today they call pultrusion, which allowed them to create these slats. Essentially, what they were doing was they were creating fiberglass ladder rail, which is the same thing, basically, as these slats. Now, I cannot emphasize how important the documentation phase was to this project. The students found and combed the archives, locating original specifications, reports of testing, and a fair number of period reports of these actual benches. Here's one from the Japanese Times. Also, as part of the documentation, the piece of fiberglass was sent to the Metropolitan Museum of Art just to confirm exactly what the matrix was, which of course it was a polyester resin. And the students also took a look at the paint layers, and they basically found that the first paint layer was, or at least the first finish coat on it, was a light yellow-green. The most significant archive for the fair is in the New York City Public Library archives. There are blueprints there, and just because it's easier to read, I put up actually the patent. And what was even more interesting was there were testing reports for these benches. They were thoroughly tested before they were ever put out in the park. Testing found that if you tightened the bolts, you would actually crack the slats. However, if you tightened the bolts so that it was short of refusal, it was very easy to remove the bolts, and they actually had a major concern about vandals. So essentially what they did to solve this problem was they put washers underneath the head of the bolt, underneath the slat, and they glued, it had to have been a form of epoxy, they glued the bolts into the aluminum legs. So when the fair was finished, the grounds and the benches were actually handed over to the New York City Department of Parks and Recreation, as we've already heard. And there was actually a fair amount of documentation for how the benches were to be prepared for this handover. A contractor was actually hired to paint the benches that were originally meant to be unpainted. And a big note was made that the slats were not to be removed. Anyway, they were painted with a marine grade paint, and needless to say, those benches have been painted many times since. By 2013, there was really a great concern amongst several people in parks that these benches were going to be lost forever. So the fiberglass slats actually in the benches, if you go to the park, you'll find that many of them have been replaced with wood. And I'm going to verify here, I actually sat in both types of benches. Those fiberglass slat benches are so much more comfortable than a wood slat bench. So anyway, the Parks Department wanted this bench, at least one of them left as relatively intact. So we very carefully selected actually a bench. We went through the park finding a bench with intact slats, and one where none of the slats appeared to have been replaced. While there may be close to 36 benches left, most of them are not intact, and what you'll see is what you see on the screen here. That essentially when these slats are broken, they just cut them off, at least if the break is at the ends. And while we were there, we actually saw a slat being broken as they were setting up for the US Open. Now, when they replace the slats, one of the things that happens is that the opening where the bolt goes in on the slats widens, so they have to use a washer. So it's fairly easy to tell which ones have been replaced. The other problem was we could see when you go back, you could see the white there. The mat actually was not very well embedded in the resin. So in the fall of 2014, an intact bench with its original fiberglass slats and aluminum legs was delivered to the Conservation Laboratory at Columbia. After their very thorough documentation, the students undertook a conditions assessment. And the bench that came to Columbia did not look very impressive. The slats were heavily painted with up to 10 layers of paint, and the paint was peeling badly. Also, the aluminum had paint drips everywhere, as you can see in this image. And we'll be focusing here on the FRP instead of the aluminum, although the aluminum was actually quite interesting for treating. Now, the thing about FRP is it can deteriorate in a number of ways, and we saw some yesterday. But the most significant is weathering and exposure to ultraviolet light, or what we call UV. As the resin deteriorates due to this weathering, the adhesion of the matrix to these glass fibers actually weakens. And once these fibers are no longer embedded in the resin, they lift from the surface, and you get glass fibers sticking out, and this is called fiberglass bloom. And in fact, let's see if I can get there we are. This is fiberglass bloom all along here, and this is actually what's a little bit left that was under the bolt head of the gel. Oh, it doesn't matter, we can go on here. The other thing about this fiberglass bloom, what it does is it allows water to get wicked into the surface, which deteriorates the surface and also causes it to usually yellow, but it certainly discolors it. And the best way of preventing this essentially is to make sure that you've got a good gel coat on here and to make sure that you're not getting any ultraviolet light. So sometimes you will also find this stuff painted, which is a good way of keeping it. Now, gel coats that are too thin do cause fiberglass to deteriorate more rapidly, and we suspect that this is what happened to these benches. This gel coat was less than 1/16 of an inch, and by the time they had sanded it for painting, there really was none left. Now, fiberglass, particularly thin slats, are easily damaged due to movement and structural stresses, and of course, impact damage. It's a crack in this image here, and actually there were not a terrific number of cracks on these benches. It was generally more a part of impact damage that was causing most of the problem. So after gaining an understanding of the deterioration mechanisms on the FRP, the students got to work. Now, because documentation indicated that the benches hadn't been painted, because the paint was not particularly well adhered, and because in order to assess these slats they had to remove the paint, it was decided that all the paint was going to be removed. And here's an example of sort of the typical paint condition. Various paint strippers were tested, and a pH-neutral stripper was selected. Now, one of the other issues with this was that there were, because it was at a university, there are things with safety, dwell times, and location, and that dictated some of the stripper parameters. So soy gel, actually manufactured by Franmar Chemical, was the one selected. And of course, the decision was made not to remove the slats. There were too many warnings about that. A special tool had been delivered to the conservation lab, and there was an extra bench that we did try removing a slat from. It caused damage to the bolt head, and it also damaged the slat itself. So the decision was not to touch the slats. That made stripping the paint actually quite difficult. And also, just as an extra special, the fiberglass fiberglass fibers gave great fiberglass splinters, which were rather painful. Now, once the paint was removed, the color of the slats was discovered to be a very nice green that everyone, including the Parks Department, liked. There was staining in some area, as you can see in the forefront of this image. And although people had thought about painting these benches again because of the bloom, there was a whole discussion about it. It was decided because this was really going to go to a museum that it would be okay to leave this unpainted. Now, we did warn the museum that under no circumstances were they allowed to anyone to sit on it, and also they were not to be touched because really these protruding glass fibers were too much. If the bench went back to the park, it would have had to have been painted. And the students also put together a whole set of specifications for the park about what to do with these benches if they went back. The other thing about, before I go on to that, the aluminum legs on this were actually cleaned of corrosion. And they had to be coated, and they were lacquered and waxed, because if they weren't, they actually corrode very quickly. And this left with an easy maintenance for the museum on this, that you basically had to use a damp rag or used a pH-neutral detergent, but you did have to continue to wax the legs on a regular basis. Now, repairing gel coats is not particularly easy, and it's particularly bad if you don't know the matrix, the resin matrix. Because the students had already done this, they knew basically that it had to be a polyester resin. And if you're fixing these kind of benches, it's not very difficult. You just have to know how to treat it. So essentially, scratches just get sanded out. But in this case, of course, since somebody had removed completely the gel coat, you would still put a gel coat back that was a polyester resin. For gouges and deep scratches, you put a sympathetic filler in and then the gel coat over it. Now, what is problematic about repairing these benches is how close the slats are to each other. So in addition to this, as I said, the students figured these benches had to be repainted again. So in these repairs, you could do these repairs without having to match the color of the original benches. And of course, a marine grade primer and paint would have to be used. And they did recommend matching the original color. Actually, to go back, one other thing, they did recommend that if these benches had already lost their slats, rather than using wood slats, they should use a fiberglass slat again. And they should make up extra slats for the maintenance of this, so that if the slats got broken, the Parks Department could then just interchange new slats. And that if you had a bench with all new slats, this meant you wouldn't have to paint it every 5 years, probably longer during parks, and therefore it would be a much easier maintenance. Now I'm going to go quickly into some other structures here that we're looking at, because the fiberglass structures at the fair, most of them were much more complicated than the bench, particularly the pavilions. And all that remain of the fiberglass pavilions at the fair are two small ancillary structures. Now, as with all good projects, there was a team heading, and this was headed by Silman, with Ed Mead at the head. Amy Wang and Sylvester Black were assisting there. And Jablonski Building Conservation, with my colleague Brandy Hayes and myself, was also part of the team. Now, the 3 fiberglass pavilions were built at the Marina of the fair, which is right next to the water. And they were part of an experimental application in the use of these materials. 2 other pavilions actually had similar products. One was the 7-Up Pavilion, which is a 2-story central structure here, and 18 canopied modules. The other one was the West Virginia State Pavilion, which actually had 2 FRP domes. Now, the marine pavilions were designed by the architectural firm Silman Associates and the engineering firm Strobel Rungvad. And the FRP panels were fabricated by Ray Green, remember that 1942 boat, his company. And originally, we had known that most of the pavilions at the fair actually had been, the fiberglass had been fabricated by Owens Corning. We found a later little booklet here, and you'll see one of those little pavilions showing up on their booklet, so we know that they had to have supplied the FRP. Now, the marine pavilions were built with 12 FRP prefabricated sandwich panels, and they had joints at the 4 axes of symmetry, and the panels were connected with these little locks called Roto-Lock connectors. And one of the things that made these pavilions was, you see this glass, this infill panel here. They were actually infilled with glass and aluminum mullions, which enclosed and supported the structures. And then they were anchored, let's see if I can get this, right here in the corners, down with steel into the foundations. Now, as with the benches, these pavilions were not originally painted. They had a colored, in this case, white gel coat. At the end of the fair, these structures were auctioned off. One private buyer bought one of these pavilions, disassembled it, and moved it to the Adirondacks, where it's actually still in use. And a contractor purchased the 2 other pavilions, but what he did was he stripped out the glass and aluminum enclosures and took those. He didn't think the FRP shells had any use. Now, just to take a quick look at what the construction is here, this is a sort of not-to-scale sandwich construction in section. And you can see there's a top skin and there's a bottom skin, and in the layer of these pavilions, there's actually polyurethane foam. And the blocks actually, it's a 1/8 inch skin, and the foam is 2 inches thick by 4 inches wide, and they're preformed blocks. The interesting thing is in the other 2 pavilions, they actually used honeycomb paper instead of the polyurethane foam. Another interesting point was they used shear ties because nobody quite knew how this stuff worked, so to tie these 2 skins together, they had the shear ties that you see here. And then to hold these different panels together, we had this Roto-Lock that was used on all of these RFP pavilions. They were on intervals of 12 inches on center for vertical joints and 8 inches on center for horizontals. The thing about it is that the center disc here was a nice copper alloy, and the rest of this lock was a ferrous metal. Time, poor repairs, and a lack of understanding of how to maintain FRP structures and their construction has taken a significant toll, actually, on these pavilions. While the actual material issues with the FRP are very similar to those found on the fiberglass benches, they are compounded by major structural issues here. Silman Associates undertook the structural analysis, and if I make a mistake here, I take full responsibility for it as I'm interpreting this. Now, the FRP actually deteriorates from movement and thermal stresses. And one of the things is in sandwich construction, what can happen is you can get air in the middle between these skins. And when you do, it heats up, you can expand and contract, and it causes rippling of the skins. So after the 2-year mark at the fair, when they started to disassemble these pavilions, they actually did an analysis on all three types of pavilions, the 7-Up, the West Virginia State, and these 3. And what they found was the 7-Up and the West Virginia pavilions actually were quite severely deteriorated. What had happened is the paper honeycomb in the center had actually caused delamination of the skins from the core. However, the marine pavilions were just fine, thank you. But what's happened since they've moved the structural support of the infill panels of the glass and aluminum out, the wind loads, as you start getting storms and heavy winds, have actually caused these pavilions to move extensively, and you get the kind of cracking that you see here. And the other point to this cracking is you can see with the ferrous metal the corrosion staining coming out of the joints. The other thing you get snow loads, which have not been as significant, I think, and we already heard from Nancy about the problems with foundations here, and so there are sort of settlement in this, which has also caused some cracking. But this is not the only problem. We have impact damage. The most severe damage was caused when a car hit one column leg, and you can see the crack at that joint is quite large. There's also the problem that people have been climbing up the pavilions, skateboarding on top of the pavilions, riding their bikes up the legs, kicking soccer balls on the interior. And here's a case where somebody probably was on their skateboard and fell, and you can see where their elbows came down. They were quite lucky they didn't fall down. To top this off, because people don't understand about how to treat FRP, here was a contractor that came in to paint it, and what he did was he took the gel coat off. They sanded it completely down, and you can see where it's completely lost where the brown is. Now, I'm sure the gel coat had its problems with cracks. It was discolored, but I think they just didn't understand what the purpose of that was. Then we've also got the fact that we have embedded steel in these legs, and what happens is when these joints open and they crack due to thermal movement or wind movement, we get water infiltration, which leads to corrosion of the steel, which leads to widening of the crack joints, and on and on and on. You can see that there's significant paint loss at the top of the pavilions, and because it sits on the gel coat, this matters. This is what's protecting the fiber mat. Now, what's interesting is the fiberglass bloom on these pavilions is not actually particularly bad, and I think it's because what they did was they embedded the mat into a resin quite thoroughly. We also have biodeterioration, biodegradation of this thing, and one of the worst of it is where water gets trapped in the panels and in the foam, and it offers excellent breeding ground for things like the moss that you see here. Now, if it was a matter of solely repairing the FRP, there would be a number of options here, and most of the repairs would be relatively simple, with the exception of how to deal with the foam in the few areas where we actually have these open joints which expose the foam. But unfortunately, it's the structural issues, I think, that are going to be one of the factors that defines how these are treated. The removal of that window system has caused a major problem. The leg where the car hit is actually quite unstable. But in the end, it's probably going to be the deterioration of the Roto-Lock that's going to be defining most of all how these are repaired. If these are the locks that are holding these panels together, because they've completely deteriorated on the Ferris portion of this, that essentially they're going to have to, am I out? Okay.
Take a minute or two more.
Okay.
And then we'll be done.
So one of the things is that although these poor pavilions have been mistreated and not particularly well taken care of, you can see what happens when something is. This is the Adirondack Pavilion here. So these things can be repaired, but I just want to point out that these had to have been an inspiration here. There was a magazine article about 12 additional FRP houses that were built by a company in Connecticut. And 3 of them are in Southbury, Toland, and Bristol. Have not been able to locate them. But somewhere out there have to be at least one surviving house that we can all go and take a look at. And finally, plastics and fiberglass are everywhere, so are inappropriate repairs. And let's not lose an important component of our mid-century modern material. Thank you.